see how to connect our PC to switch and switch to the router. And in this experiment, we are going to take three routers and three switches and six PCs. So in PCs, we need to take coming to the PCs, we need to take ordinary generic PC. Here we are going to have PCPT. We are going to take six PCs. For all these six pieces, we need to give a IP address. So you all know how to give the IP address for these pieces. So I'll be explaining that also. And next one is after taking all these pieces, we need to take our switches and we need to connect our pieces to the switches, and we need to connect our switches to the router. So next we are coming here in the cool devices. We are coming for the network devices. In these network devices, we are going to have routers, switches, and hubs, and wireless devices, and security devices, WAN emulation devices, and many more. So in the routers, we are going to take PT router. So see here, you can see in the left, you can see in the bottom, you can see here we are taking router PT. We are placing on the top. So next we need to take our switches. Switches will be the mediator between the PC and the router. So here we are taking PT switch. PT switch. After placing all this in this manner, we are going for this auto connection. This auto choose the connection type. This auto choose connection type will be automatically chosen the wire, which model wire should be connected to devices. So instead of going for all these wires, we can take this automatic and connect our PC to the switch. Once again, PC to the switch. Next, switch to the router. Switch. See, PC from the router to the router. It is going to take a serial connection automatically. If not, we need to take this serial DCE and connect from this router to router. Instead, we can take this automatic and we can connect directly. First of all, again, we need to connect our all these devices should be connected to the routers, switches. Switches need to be connected to the routers. Routers need to be connected in the serial order, and the switches should have the connection of these pieces also. So here I'm connecting the last switch to the router. After giving this connection, we are going for the IP address. So in this, we are going to give the IP address for every individual devices, like for PC0, PC1, PC2, PC3. We are going to give some unique IP addresses. So for the routers, firstly for the routers, we should give our IP address. The router's IP address will be the gateway for the devices which are connected under that. So in the router, we are going for this configuration. In this configuration, we are coming into the interface section. In this interface section, we are coming to this fast Ethernet 0x0. So in this, we need to enter our IPv4 address 192.168.10.1. So I have given this IPv4 address. So the subnet mask will be automatically generated by the network after we are entering this one. So you can see here we got the subnet mask automatically. So I'm owning this port. I was owning this port router. So the devices under this will be on. If we on this device after giving the IP address, we need to on. If not, we won't get the connection under it. We if you, can, if you want to, we got the connection. So I was closing the router and coming to this PC0. Here I am coming for the desktop. In the desktop, I was opening this IP configuration. So in this IP configuration, we need to give the IPv4 address 192.168.10.2. So what is the router's address? The router's address was 192.168.10.1. So this DNS server leave this column. So we want IPv4 address and subnet mask. That's enough. And after that, we need to enter the default gateway also. So the default gateway will be the router's IP address. Simple. And here I was changing the IPv4 Wi-Fi V6 configuration as automatic. And I was closing this PC0. So coming with PC1 desktop IPv4 same. I was doing this IPv6 as automatic and IPv4. In this IPv4 I was giving a unique address 192.168.10.3. After entering we will be generated the subnet mask automatically 192.168.10.1. So the default gateway was 192.168.10.1. So I was closing this one also. Here coming to these devices PC2, we need to give the IP addresses for this also. PC0. Before opening the PC2, I need to enter the gateway router 1. In this router 1 configuration fast Ethernet 0 by 0. So here we need to give the IP address 192.168. So here when we are changing our networks, we need to change a series of address. So in the first router I have given 192.168.10.1 as the IPv4 address. So in this router 1, I am going to change it as 192.168.20.1. So entering this number, we got the subnet mask automatically. So owning this my router 1. After that, it will be the gateway. It will be the gateway. It will be the gateway for these all devices. So I was opening this PC2. In this PC2, I was opening this desktop. In the desktop IP configuration, IPv4 automatically. So in this 192.168.20.2 unique address. So what is the gateway? What is the gateway? 192.168.20.1 is the gateway. In the PC3, same desktop IP configuration automatic 192.168.20.3. Enter. So coming to here, if we can see, we have connected these. We have given IP addresses for PC0, PC1, PC2, PC3, and for routers we have given IP addresses. So the router's IP address is the gateway for PCs, disconnected devices PC0 and PC1. So these PCs are the end devices. We call them as end devices. These routers as network devices. So in the other network, we are giving in the router 2, we are going to give. In this also, we are going to change our configuration. Coming to this fast Ethernet, we need to give a unique address for the network 192.168.30.1. Here I was changing the IP address series. So here I have taken 192.168.30.1 as IP address. So entering this one, we got this subnet mask automatically. I'm owning this devices. Router, I was owning this router device. I was closing this one. After that, opening this PCB4, PC4. In this desktop section, we need to give the IPv4 address. IPv6 is automatic. Here I wanted to write 192.168.30.2 unique address. So gateway is 92.168.30.1. So closing this one, closing PC4. So the last we need to give for this one is IP addresses. In the desktop part we need to give IP automatic IPv4 automatic. And this IPv4 2. So I was giving the unique address for this PC5. Here I was giving the gateway. So first of all, we have completed giving these IPv4 addresses for all the devices, all the network devices, and all the network devices, and for all the devices we have given we have given this IPv4 address. So next we need to on the on these routers. So if you can see all these switches and pieces are connected, and we got the green signals means they are connected automatically. So by giving this address we have connected it. So these routers need to be on. So here we need to write a series number. So all these routers are connected in the series position, right? So we need to give a series number also for these all routers. So first of all, for router 0, we need to give a series number of router 1. So we should be give this series number. So this router 0, in this router 0, we are taking this port. What is the port? Here we are taking, in this router we are taking a port series of 2 by 0. For this port we are connecting our series connection. So here we need to give an IPv4, another series of IPv4 address. So for having a difference, I was giving a unique address here. So for this route in this router 0, I was giving in this series 2 by 0. I was giving a IPv4 address 10 by 0, 10, 10 dot 0 dot 0 dot 1. So here also after entering this, we will be getting the subnet mask automatically. So here if you can see, we need to on our system. After owning this system, it is been automatically on here from the router 0 to router 1. It will be we will be getting our green signals. I was owning this system. Wait for me. It will be. Oh, sorry. We have given this for router 0. We have given the series address. So next we need to on in the router 1 also, right? In the both systems, after giving the series number in the both numbers, we will be getting in this router 1 also. We are giving the IP before address in the series 2 by 0 means series 2 by 0 in the router 0 series serial 2 by 0 is connected to serial 2 by 0 in this here also. So for the both things we are giving one series of types of address like 10.0.0.2. I was differentiating the address, so IPv4 address should be have difference, right? So after giving the IPv4 address in this router 1 also, I was on in this system. If we can see, we got the green lights. I was on offing this one. See, we got this red marks. After on this one, we'll be getting our green signals. So in this, if you can see in this diagram, for the router we are going to have two series ports. For one PT router, for one PT router we are going to have two serial connections. So one serial connection is 2 by 0. So already we have given a serial for one port, we have given a serial for serial 2 by 0 we have given address, means serial router 0. In the router 0 we in the serial 2 by 0 it is connected to router 1 serial 2 by 0. So here we have an empty one serial 3 by 0. So this 3 serial 3 by 0 is connected with the router 2. In the router 2 we are going to change the address in the serial 3 by 0. Okay, in this router 0 serial 2 by 0 is connected with router 1 serial 2 by 0. So in this router 1 serial 3 by 0 is connected with router 2 serial 3 by 0. So here in this router 1 we need to change the address for serial 3 by 0. See, it was empty in the serial 3 by 0, it was empty call. Here we need to write an address, one unique address, and in this one we got the subnet mask. I was on in the system. After that I was closing this one. After this I was opening this router 2. This router 2 I was coming for the serial 3 by 0. Here I was writing the address 11.0.0.2. Enter. I was on in this system. So after that, if we see our medium, here I have on the system. This also might be I should write this in the serial 3 2, I think so. It was not here I was on this system. We can see it was connected. So router, all these routers, we got the IP addresses for routers and PCs. So next here we are starting with our RIP routing protocols. So in this, up to here we have completed giving these are all IP addresses for every device. We have given these IP addresses. Now we need to give a routing protocol for each device, means which route it should be, the data packet should follow. So here I was taking a data packet. If you can see, uh, I was giving this PC one data packet for PC1. It wanted to transfer to PC2, so we got failed status. Why? Because there is no route. We have all the IP addresses for all the devices, but there is a no route, and every connection has been established, but in these all devices there is a no route. So here we need to give a route for all these devices. How we can give this route? By opening this router. In this router, in the routing you can see RIP routing protocols. In this we need to give the present, means in this routers, in the router, under this router, what are the IP addresses we have, and what is the series connection address we are going to have. So what is the router's IPv4 address? 192.168.10.1, right? So here I was changing it to 0 because the under devices are all will be also coming if we use this 0. So I was adding this 192.168.10 in this RIP routing. So after that we need to give a series connection also. So what is the serial number we have given for this 10.0.0.1. So I was changing it to 0. I was adding both the things. So closing this router zeros. After that I was opening this router 1. In this router 1 I was opening this RIP. In this RIP we need to give the address of the router 192.168.20.0. I was adding this address. Next is 10.0.0.0. I was adding this one also. Here I was using 11.0.0.0 because this 11 point is connected. This router 1 is connected with router 0. So the router 0's serial connection address is 10.0.0.0. So router 1 is connected with the router 2 also, right? So that's the reason I was giving 11.0.0 also. So I was adding both the things and closing this router 1 tab. In this router 2, I was opening this RIP. In this RIP, I was giving 192 present IP address 168.30.0. So I was adding this one also. In this, we have used the serial connection address is 11.0.0.0. So I was adding this one. So closing this tab. If you can see, when we have transferred PC1 to PC2, firstly when we have transferred PC1 to PC2, we got fail. So here I was taking a data packet. I was firstly transmitting a piece from PC1 to PC0. Means in the same network I was transferring the file. We got this successful. The status we got is successful. So next, same thing for both the three routers. Successful. Second also we got successful. So PC4 to PC5 we got successful. So under these networks, when we are transferring the files, are going successfully. So if we want to change our network and transmitting our devices, so here I was transmitting a data packet from PC1 to PC2. Firstly we got fail. We'll try again. So PC1 to PC2 successful. So for the first time it is showing an error, but after that if you try it, you will be getting an successful message. So doing the same thing with the PC0 to PC3. So we got failed. If we try once again, we'll be getting successful. First shoe, we got the successful also status. PC0 to PC3. So here uh, we need to do firstly, when we wanted to transmit any data packets, we need to open this command prompt, and here in this command prompt we need to enter a command called ping. So by using this ping, the routing signals, the system and the router will going to come into the communication. So they will be establishing a path. So instead of losing this data packet, we use this ping command. In this ping, by using this ping command, we can give the IP addresses so that the route will be established firstly. So by this, we will not be losing this data. So in this ping, firstly in this ping, I was giving an IP address. We are in the PC0, means we are in the first router 0, under this router 0. So we wanted to transmit data to router 1. What is the address of router 1? In the PC02, PC, let me take a PC4. What is the address of PC4? 192.168.30.2. Entering it. Firstly, it is taking time. It will be coming as timed out session. Request timed out. Secondly, we got our address. See here. If you see here, packet sent 4, received 3, and lost 1. Means 25% of loss in the data packets. When I was sending a ping message for another router, another PC, 192.168.20.2, we are getting our addresses very fastly within 1 millisecond. So see here, sent 4, received 4, lost 0, means 0% loss. Next I was giving another ping, 192.168.30.3. While we are giving new addresses, it is taking time out, some much time. In that time we are getting a timeout session. So here also we got a timeout session. After that I was giving the same IP address. Here the ping will be getting the address very fast, 30.3. See here, 4 sent, received 4, lost 0. Same addresses, but firstly we need to set our path. See here, I was taking the data packet. I was sending from PC1 to PC4 successful. From PC0 to PC5 successful. PC2 to PC3 successful. From PC5 to PC0 successful. Okay, with this, after this class I'll be giving the addresses also. For all these PCs I'll be giving the addresses also. If not, we can write our addresses here itself, like by taking this note, place a note, we can add addresses here. What is the address? 192.168.10.2. In this way we can mention our addresses also. And that's for now. Thank you, ma.